In this video, we'll explore operations with algebraic expressions. Now, an algebraic expression is a mathematical expression that will include variables, numbers, and operations. A key term here is the coefficient. That is a number that's being multiplied on a variable. So if you see like 5x, the coefficient would be 5. Other key terms include polynomials, monomials, and binomials. A polynomial is a sum of a finite number of algebraic terms with non-negative integer powers on the variables, whereas a monomial is just a single term and a binomial is a two-term polynomial. So let's look at an example. We want to know, is this algebraic expression a polynomial? Well, I'll first look at my variables, and they are all non-negative. Then I can say, well, is this a sum? Yes. Now, some of you might say, well, wait a minute, that says minus 9x. That's the difference. But remember, in algebra, minus 9 is equivalent to plus negative 9x. So therefore, even when I see minus 9x, I recognize that as technically a sum. Now compare that to the quantity 3x plus 12 divided by the quantity 14y minus 13. Here, that has division between the two expressions. Therefore, that's not a polynomial. It is still an algebraic expression. Now we can also simplify expressions when we're given values to plug in and substitute in for a variable. We just want to make sure to simplify after we substitute. So say we have negative 4x cubed plus 9xy minus 4y, and we're going to substitute in 2 for x and negative 5 for y. So we start there. We start with the 2 and plug it in for each of the x's, and we take the negative 5 and substitute in for both the y's. Now it's important to remember that this x cubed is its own quantity being multiplied by negative 4. It is not negative 4 times x quantity cubed. That's important. It's just the x cubed. So I'll start with my exponents, and then I can start doing some of the other multiplication along the way. So 2 cubed is 8, 9 times 2 is 18, and negative 4 times negative 5 gives me positive 20. I want to finish off my multiplication here, and then I can start adding my terms. So negative 32 minus 90 gives me negative 122. And then I'm going to add the 20, which will give me negative 102. We can also combine polynomials if the terms have identical variables. And that's the key part. If I want to add or subtract them, they have to be identical. Just follow your order of operations and use the distributive property whenever you need it. So let's look at this example here. I have variables that have r's and q's, but it has to be identical. The only ones that have identical variables are 9rq and negative 6rq. They're the only two terms I can combine. And I can say then the coefficients, I'm going to subtract them. 9 minus 6 gives me 3rq. I can't do r squared and r because this has an exponent and this one is to the first power. So this is my final solution. Now here at this example, we step it up a little bit. First thing I would do with this is distribute. So I'm going to distribute my 3m to my two terms inside the parentheses, and I'm going to distribute a negative p to the two terms in this set of parentheses. That would mean that I'm going to be looking at 3m times the quantity 5mp plus 3m times the quantity negative 6pw squared. Then I'm going to be looking at minus p times the quantity 8m squared, and then minus p times negative 13mw squared. And I keep these signs, the operations, on the variables. If I treat them kind of like it's a positive or negative, it makes it a little bit easier for me to remember whether it should be positive or negative when I multiply. So here, 3 times 5 is 15. M times m gives me m squared, and then the p. And then same thing here. 3 times negative 6 is negative 18. And then I have the mpw squared. Here, negative 1 times 8 gives me the negative 8. And then I've got the m squared and the p. And then the negative times a negative will give me a positive 13 mpw squared. And you may be wondering, why did I put the variables in the order they're in? Was I just trying to make it look nice? No. It is very commonplace for you to put variables in alphabetical order. That's why even though in this one the m is on the outside and the pw are on the inside, I still put the m first. And here it was mw squared. I put the p in the middle because of alphabetical order. It then helps with the idea of knowing what can I really add and subtract. Well, here, this has m squared p, and this has m squared p, so 15 minus 8 will give me 7. This has mpw squared, and this one has mpw squared, so that would give me negative 5 mpw squared. And there, I can't combine it anymore. It's to its simplest form. Now, when I start integrating more multiplication division, the first thing I look at is, do I need to distribute? And then I'm going to follow my rules for exponents. Do I need to add exponents when they're being multiplied, if it is identical variables? And if it's division, I need to subtract those exponents and make sure to keep the variable wherever it is in the fraction that the variable is greater, has the greater exponent. And then if there is any addition or subtraction, can I combine anything in the end? So let's look at an example. Here are three monomials being multiplied together. What I would do when I have monomials like this, I would change my multiplication. Because it's commutative, I can change the order, so I can put all the constants or all the coefficients together, all the g's together, and then all the k's together. It makes it easier to figure out what I'm doing. So I'm going to reorder it as negative or positive 6 times 4 times negative 2, and then the g times g cubed times g squared, and the k squared times k squared. Now it's really easy to see how to do my multiplication. I multiply my three coefficients to get negative 48. Then I can say I'm multiplying through the g's as my base, so I'm going to add the exponents. This is a 1 plus 3 plus 2, and this on my k's is 2 plus 1 plus 2. Simplify one last time, and I have negative 48, g to the 6th, k to the 5th. Now, what if I have two binomials being multiplied together? I have to remember to distribute to help me out here. So I take my 4a and I multiply it to both terms in the second binomial. So that would be 4a times 6a plus 4a times the negative 7. And again, this was positive, so I make it a positive 4a. This was a minus 7, so I'm going to make it a negative 7 just to keep it simple on where the positives and negatives are. Now I need to do the same thing with the plus 5b. So I'm going to distribute the 5b to both terms. So this is plus 5b times 6a and plus 5b times negative 7. Now I'm going to simplify each term, and I've got 24a squared minus 28a plus 30ab minus 35b. And nothing there can then be combined because there's no more identical terms. Now what if I had an expression where it's 18p to the 5th r plus 9pr to the 7th, that quantity divided by a monomial, 9p squared r cubed? I can distribute that division to both terms inside that polynomial and simplify them separately. So this would become 18p to the 5th r divided by the 9p squared r cubed, and then the 9pr to the 7th divided by 9p squared r cubed. And I can then simplify individually. 18 divided by 9 gives me 2 over 1. And then I can look at my p's and say 5 is greater, so I'm going to do 5 minus 2 in the numerator. If the r's, 3 is greater than 1, so I'm going to put r in denominator and do the exponent of 3 minus 1. With my second fraction here, 9 divided by 9 is 1, hence why I put a 1 over 1, just to help me with that placeholder. Then I can say, okay, my p's, 2 is greater than 1, so I'm going to put p in the denominator, and I'm going to do the exponents of 2 minus 1. And lastly is my r's there. That's 7 and 3, so I'm going to say that's in my numerator, r to the 7 minus 3. Simplify and say, well, I can't combine them anymore because they're different denominators. I can finish here.